Okay, so I think so far we have done a lot of complex and fundamental stuff related to locomotion. So we have these sort of turn in place and movements, additive leans, plus toggle between multiple different movement states, right? And everything seems pretty much good, but I think one more fundamental thing that we can add this to here is that uh, jumping, right? So currently if you press space button, it doesn't jump because obviously we haven't implemented that feature yet, but ideally we should be able to add that feature for a game. Okay, so where can I start? So first of all, since this is sort of a new feature, I will close the unnecessary stuff for this specific section. So we need obviously to be have this ABP locomotion and we may need this BPC locomotion system component, and we need this BP player base, and I think yeah, plus we may need this data table. I think those are the four that we mainly require right now, and I'll close the other tabs. Okay, so let's start from BP player base. So like we add for the other input actions, we need a new input action for jump, right? So let's go to the TPS game, input actions, character, and here let's create a new input action called IA jump. Okay, right. Now as the triggers, let's add two triggers, one trigger for pressed and another trigger for released. Okay, that's it. And let's go to the input mapping context, and let's add that new input action, IA jump, right? As the input, I will add spacebar, and we don't need any modifiers or triggers. Okay, this error is common, right? Just ignore it. And now let's go to the player base. So this is a previous input action that I've been added for sprint, so I'll comment that thing as well. Right. And then what we can do is let's call that input action jump here, and what, let me quickly look at my documentation. Yes, so at the started, let's add jump, and at the completed, let's add stop jump, right? Actually these functions comes by default with the character class, so you can see the class is target is character. So these are default functions that is provided by Unreal Engine if you have your parent class as a character, right? So here you can see our parent class is character based, but if I go there and open it out, then the root parent class is simply a character, right? So all those features will be by default inherited by this player base, right? Okay, let's compile and save and play it again. You can see whenever I press jump or press space, it's jumping, right? But obviously it doesn't play any animations or stuff like that, right? So let's implement those stuff. Okay, so that's the first step we have to do. Then let's go to the AVP locomotion, right? And there let's add a new class, right? I'll call it as not a class actually. Let's add a new function and I'll call it as update character state data, and I'll make it as thread safe, because later on actually we are going to add much more different character state data that is going to be injected outside of this specific animation instance class. So therefore it would be nice to have a specific function to handle or organize all of those state data for us. So I'll assign it to the blueprint thread safe functions, and as an input I can give the delta time, which is float, right? And then inside the blueprint thread safe update animation, maybe after this update wall detection heuristics, let's add that function, and I'll copy this delta time and attach it to here. Okay, and let's go inside this function. So I'll add a sequence, right? And we need two different states now. So first thing is for is jumping, and this should go under character state data, and I'll copy and drag that pin and set it as false by default. And the next character state is falling. Again, this is a character state data, and by default it's false. And now let's get the property access pin, right? So there, let's go to the get movement component. We should have a variable called movement mode, and I'll get the enum, right? So this movement mode actually comes with the get movement component by default. And let's say if it is falling, which means we are now at jumping state, right? So if it is true, plus we have the world velocity, right? And I'll split this pin, and since I'm doing the jumps, I should be able to look at the C value of the world velocity, and if it is changing, then possibly we have a like sort of a z-axis related movement, right? So I'll check whether this one has a value, which means we have a velocity towards z-axis, which means we are jumping or either falling, right? So if I have a c velocity greater than 0, which means we have a velocity to the upside, which means we have a possible jump. If it doesn't have a positive value, which means we have a negative value which is not equal to 0, then we are falling, because the vector is actually pointed to the down direction. So if it is positive, then we are jumping, is jumping true. If it is negative, then we are falling. image is falling is true. Right? So this update will have this update reinitialization will happen for each frame. Right? Okay, and I'll comment all of these as maybe let's say in air state. Okay, right, and then yeah, then maybe we can test these variables, right? So first I will go to the event graph. We have this update anim function. I'll add a print string, and let's first test this is jumping thing. Right, I think you have to go for a different class, because if you are rely on this ABP locomotion and start playing, it will print this false print string by default as well. But if you go for a different class and play it there, then that won't be happening anymore, right? So you can see when I'm jumping it is becoming true, and when I'm falling it becomes false, right? Okay, which means it's worked properly, so I can remove this print string. Right, so that's the first step for the jump. And let's go to the anim graph and let's set up the basic state meshing states and transitions for us to perform this jump related transitions, right? So the anim graph, let's go to the locomotion, right? So here we have all those state for the basic locomotion movements, right? And similarly, let's add a new set of states at here maybe to perform those jumpings, right? So the nice feature of Unreal Engine 5 is basically we have this state aliases node, which means like you don't need to plug all the nodes to the same states like we did before when we are using Unreal Engine 4. Instead of that, it simplifies the process and it would give much more cleaner looking state machines for us, right? So there won't be pins or transition arrows like this everywhere. Instead of that, we simply like chunking the state machine by using these state aliases, right? So first let's add a state alias called jump sources, right? So I can jump from idle state or cycle state or start state, stop state, or the pivot state, right? And then I can add a conduit, right? So conduit is basically a logical flow control, which means like we have multiple different transitions that are outgoing edges from this specific node, and based on the sufficient conditions it will forward that execution for that specific transition path, right? So that's the use case of this conduit node. So since this is sort of like a control or the selection, I will name it as jump select, right? And then let's have a new state called jump start, and from jump start I can go to the jump start loop, and from there I can go to the jump apex. Okay, and then from jump apex it can go to the for loop, because now we are falling. Plus the jump selector can directly jump to the jump apex as well in case this transition path fails. Okay, so jump apex to for loop, plus we can have a new state called jump start to for loop, right? Because instead of going to this jump start, we can have an immediate fall as well. For example, let's say if our character is at a cliff and soon after he popped out of from that cliff, it will be falling instead of jumping, right? So instead of playing the jump start and jump start loop and jump apex, we can simply play the fall loop, right? From the jump start to fall. So I'll add a new transition like this. And finally, we can have a for loop directed like this as well. Okay, then once the for loop has been finished, now we are at the ground. So soon after the character hit ground, we should play the fall land animation. So I'll add a new state called fall land. Right. Also, this states can be interrupted at certain places, right? So I'll add a new state alias called jump fall interrupt sources. Jump fall interrupt sources, right? And what are the interruptible sources? Well, basically the opposite of jump sources are the jump interruptible sources. So jump start loop, jump apex, for loop, jump start to for loop, and fall land are the possible interruptible sources for our jump fall, right? And then I can have one more state conduit which is end in air, right? So sometimes let's say our character die on air, or maybe the game is over at air or something like that, some sort of a unavoidable interrupt, then we can go directly back to these sort of states, right? So maybe I can go to the cycle state. Therefore I will add a new state alias called cycle alias, and it will be pointing to the cycle state, right? So basically this execution path including this state is exact same like we add a transition like this, right? But if I add a transition like this, the state machine is not clean enough, right? But if we have something like this as a state alias, now it is much more cleaner, right? Okay, so those are the possible state that we should have, and if I compile it, now it gives these sort of warnings for us, because obviously we have to implement these states and the respective transitions. But I think if I continue those implementation within this video, it will be a bit longer. So I'll stop the first part of jump section right here, and I'll continue the second part at the next tutorial. I'll see you there. Thank you.